In this video, I am going over 10.4, which is now introducing the geometric sequence. So a geometric sequence is when you're taking each term and you are multiplying it by what we're going to call sorry about that. We are multiplying by what is going to be called the common ratio, our constant here, to extend that sequence. So like this example in U try, so that you could see what we're going to be working with here. So like for example, here I notice I'm going from 3 to 9 to 27. And so in this case, we are multiplying the common ratio R here is 3 because 3 times 3 is 9, 9 times 3 is 27. So now we can just go ahead and extend it. So the fourth term in the sequence is 27 times 3, which is 81. The fifth term in the sequence is 243. And then the last term here that we'll be stopping at the sixth sequence number in the sequence is multiplying 243 by our common ratio of 3, and you get 729. So go ahead and pause the video and try this. You try on your own. And here we go. So in this one, the common ratio, will notice you are dividing by 2 or multiplying by 1/2 or 0.5. So here that means the fourth term, you should have gotten 5. Then the next term here is 5/2 or 2.5. Then the last term here in our sequence, the sixth term, is 5/4 or 1.25. Now our main focus in this lesson is to identify what is the sum of a geometric sequence. And this is our formula that we are going to use, where if you're given n number of terms, and you'll always be given that value, here to find the sum, we're going to use this formula where the sum, S sub n is the sum. So this is what our formula is equal to. A sub 1 is going to represent the initial value, the first term in our sequence. And then R, again, is representing our common ratio. So in order to calculate the sum of a geometric sequence, this is what we're going to be using here. So like, for example, here you're given this geometric sequence starting at 4. What is the sum of the first 10 terms of the series? So here again, we're looking for the sum or sum of the first 10 terms. That's what we're looking for. So here in this case, if you notice, we need our first term, a sub 1. Well, a sub 1 is 4. We also need n. Well, n is 10 because that's the first 10 terms that we're finding the sum of. We also need to know what is R, or what is the common ratio. We'll look at the sequence here. What am I multiplying by each term to extend? We're multiplying by 2. So now that I have my pieces, we can now find the sum of the first 10 values, which is a sub 1, which is 4 times 1 minus your common ratio R, which is 2, raised to the 10th power. Then we're going to divide that by 1 minus 2. That is R for your common ratio. And so here, putting that in the calculator, the sum of the first 2 terms is 4,092. So go ahead and pause the video now and try this. You try on your own. And here we go. So again, we are now looking for the sum of the first 8 terms. So we're looking for S sub 8. That is what we are finding the sum of. So here, our first term you should have identified is 64. Then again, n is 8 and our common ratio. So here, what are you multiplying by? 1/2 or 0.5. So you should have set this up as, so we're looking for, again, the sum of our first 8 terms. So 64 times 1 minus 1/2 being raised to the 8th power. And divide that by 1 minus your common ratio, which was, again, 1/2. Here, when you put that in the calculator, the sum of the first 8 terms in this geometric sequence is 127.5. So now in example 3, we are again finding the sum, but a little different. We're finding the sum of the first 12 terms. So again, we're looking for S sub 12. In a geometric series sequence, given the first term is 2 and the third term is 32. So notice a little different. So the first term, A sub 1 is 2. We're looking for the sum of the first 12 terms, so n is 12. But do we know what the common ratio is? No. So we have to first actually find what r is. We know that the first term is 2, and we know the third term is 32. So here we're thinking, okay, what number? Now, one way of setting this up as well is you could have, well, 32 is equal to, we're starting at 2 and we're multiplying, right, by the common ratio once and twice to get the third term. So we are multiplying r times r, which is r squared. Now we're solving for r. Well, I need to divide by 2, and now I have 16 is equal to r squared. Then take the square root, and r is equal to 4. So now you could see 2 times 4 is 8, and 8 times 4 is 32. So notice how that, again, works in. So now we can go ahead and use our formula. Where here we're finding the sum, so using our initial 2 times 1 minus 4 to the 12th power. Then divide that by 1 minus 4. And the sum of the first 12 terms is 11,184,810. So go ahead and pause the video and try the U-try on your own. And here we go. So again, you're finding the sum of the first 8 terms. So we're looking for S sub 8. Here, you're given the first term. So you could identify that the first term was 5. And here we're looking for N, which is 8. But again, you don't know what R was. You were given the fourth term, though, was 40. So we know the first term is 5. Then we don't know the second. We don't know the third, but we know the fourth term is 40. So notice how you're multiplying by r, not once, not twice, but 3 times. So you could set this up as 40 is equal to, well, 5 times r to the third power, because you're multiplying r 3 times. Now I can divide by 5. And here I've got 8 is equal to r to the third. So now notice we're going to take the cubed root of 8. And the cubed root of 8 is 2. So now we can go ahead and find the sum of the first 8 terms. So we have our initial value of 5, then times 1 minus 2 to the 8th power. Divide that by 1 minus 2. And so here, when you solve, you should have gotten that the sum is 1,275. Now in example 4, we are given the ratio. So the ratio between the terms is 5. The sixth term is 21,875. We're going to find the sum of the first 8 terms of the geometric sequence. So here we have the ratio, which is 5. We're looking for the sum of the first 8 terms, but we were given the sixth term. We were not given the first term. So now we've got to figure out what is the first term in order to figure out the sum. So again, we know we don't know the first term, but we do know second, third, fourth, fifth, and sixth. We know the sixth term is 21,875. So that means if we're trying to figure out what is a sub 1, what is our first term here? Well, you have to multiply r, if you notice, how many times? 5 times. So we can still set this up as 21,875 is equal to, we don't know what the first term is, so I'll leave it, but times now r raised to the 5th power. Now, technically, do we know what r is? Yes, we know r is 5. So I'm going to go ahead now and have times 5 raised to the 5th power. So here we've got 21,875 is equal to a sub 1 times 5 to the 5th, which is 3,125. So now if I'm trying to solve for that first term, but it's being multiplied, now divide by 3,125. And here the first term, when you divide this, you should get 7. So now that we've got our first term, now we can find the sum. So this is 7 times 1 minus 5 to the 8th. Divide that by 1 minus 5. And here the sum of our first 8 terms is 683,592. Now go on and pause the video and try the U-try on your own. And here we go. So here you are looking for the sum of the first 12 terms given the 10th term, and the common ratio is 3. So we know that the ratio is 3. We know that we're looking for the sum of the first 12 terms, but again, we are trying to figure out what is the first term. Well, we know that the 10th term is 98,415, which is equal to, we're going to take that first term and we multiply it by our ratio 3 9 times. So you should have set it up as 3 to the 9th. So now here I've got 98,415 is equal to that initial value, but then 3 to the 9th power is 19,683. Then we're solving for that first, but it's being multiplied. So now divide by 19,683. And so now here, when you divide, you get that first term is 5. Now you could set up and solve. So you should have set it up as 5 times 1 minus 3 to the 12th power. Divide that by 1 minus 3. And so here the sum is 1,328,600. Now here, this is for those who wanted to try this word problem. So if you want to go ahead and pause the video and try this one, go ahead. And here we go. So Samantha's dad gives her a push on the swing. At her highest point, she's 5 feet off the ground. That is the initial. So our first swing, she is 5 feet off the ground. But if he doesn't give her another push, each progressive swing will be 25% of the height of the previous, which is the ratio, 25% or 0.25. That is what we're multiplying by. So how would you find the height of the next 4 swings? Well, if the first swing was 5, then that means to find the next 4 swings, all you now have to do is multiply by 0.25. So here you end up with 1.25, 0.3125, because all we're doing is multiplying by a common ratio of 0.25 or 1/4. So here, and we could keep going, and 7, 8, 1, 2, 5. So again, you're just extending that sequence. But if you wanted to also know what is the sum of the first 10, that means n is 10 in this case. So if you wanted to find the sum, this is here 5, because of the initial was 5. So 5 times 1 minus 0.25 being raised to the 10th power, then divide that by 1 minus 0.25. And here you get that the sum is approximately 6.67 feet. And then there were about 3 practice problems on that we included in today's lesson. So if you want to go ahead and pause the video and try the 3 problems, go ahead and let's see how you do. And here we go. So let's see how you did with the 3 practice problems. So here, to find the sum, identifying, you should have identified that the first term was 1,536. We are looking for, so n, oops, sorry, not m, n, we're looking for the sum of the first 7 with a common ratio of 1/2 or 0.5. So you could have set this up as 1,536 times 1 minus 0.5 raised to the 7th power. Divide that by 1 minus 0.5, and you should have gotten A. Then number 2, again, finding the sum, A sub 1, so the initial first was 2. We're looking for the sum of the first 8 terms, and then the ratio according to the sequence given was 3. So setting this up was 2 times 1 minus 3 to the 8th. Divide that by 1 minus 3, and you should have gotten C. Then question number 3, again, finding the sum. So you have A sub 1 was equal to 3. We're looking for the sum of the first 10 terms. However, you are not given the ratio. You were given the third term was 3 and the first term, third term was 75. So you should have set this up as, if you wanted to solve, 75 is equal to 3 times the radius squared. Or you could have also, just done mental math, figuring that out. So here I'm going to divide by 3, and now I've got 25 is equal to r squared. So you had that ratio of 5. So setting this up, you have 3 times 1 minus 5 to the 10th. Divide that by 1 minus 5. And here you should have gotten B.